You know, I've been very reflective in the last decade because Cardano just went through a major upgrade. We embraced governance. We embraced on-chain representation. For the last 2 years, the ecosystem's been working very closely together, workshops in dozens of countries, people from all around the world trying to figure out how do you build an online government that allows you, as an ecosystem, to make decisions about budgets and roadmaps, upgrades. When you look at Windows, you got Microsoft. When you look at the iPhone, you got Apple. You have companies behind these big, complicated things. But protocols don't have companies. They have supporters, they have people that work with them, people connected to them. But at the end of the day, if we say we're decentralized, who's in control? Who's in charge? So we've been trying to solve that problem. On-chain government. The consent of the government, the institutions, writing a constitution. I was down in Argentina. We're having a constitutional convention there. Boy, that's going to be fun. Delegates from 50 countries, 63 different workshops to vote on a constitution. And as fun and exciting as that is, that's not what I'm here to talk about today. Talk about the future. See, I think about cryptocurrencies in terms of generations. I've been in this space for so long, I was actually in the middle of the very first generation, Bitcoin. So in 2010, 2011, nobody was in it for the money. I know that because there was no money. We had to buy our own coffee. Nobody knew what Bitcoin was. They thought it was a cult, probably still is. And what was fun about it and exciting about it is that we had these broad aspirations and goals of where we wanted to go and what we wanted to do. It was the cypherpunk movement that came from the 1980s. Information moves instantaneously, so money should. Email for money, let's do that. Then Bitcoin started catching on. First generation was about decentralization, disintermediation, this idea of being your own bank. Mission accomplished. Well, what's the first thing you do when something is successful? You criticize it. We love the iPhone, but we love Windows, but we love Android, but. So we love Bitcoin, but we don't have programmability. So the second generation came, and the second generation was about smart contracts, programmability. Eureka! At the time, everybody thought we were crazy. But in hindsight, it was like when JavaScript came to the web browser. You had these static websites. They could be pretty, but you couldn't do much with them. JavaScript comes, and you have Amazon, and you have Facebook, and you have Google. You have all these amazing things. Eureka! Awesome. And when we have programmability, what do? We say, well, that's all fine and dandy, but damn, it's expensive. Apparently, building a virtual machine, a shared state amongst millions of people, a finite resource, doesn't scale very well, does it? Second, how do you get it to work with everything? Where's your interoperability? And yes, what Cardano's dealing with right now, how do you build a government? Because you're not dealing with a simple utility, digital gold, teleporting Bitcoin around. You're talking about a programmable system. So you have to upgrade that system. You have to evolve that system. You have to make that system better. Okay. So the third generation comes in, and there's tons of booths all around. You see them. And they talk about scalability and interoperability and governance. You have your SWEs. Congratulations on Circle. Missing anyone? You have your Aptos. You have all of these people, Algorand, Solana, and yes, Cardano. And we're all fighting, and we're in the middle part of the third generation. And it's exciting and it's fun because every time you have a generation, you get a whole new scale of capabilities. When you have scalability, it means it's cheap to use the systems for millions of people. When you have interoperability, it means your systems talk to each other. You can truly build an internet of money. You can build an internet of finance. It's awesome. And when you have governance, it means you harness the wisdom and the capabilities of millions of people throughout the world, the wisdom of the crowds. Suddenly, the people building on your system are your product managers. The engineers building dApps and DeFi are the ones talking about how to improve the protocol and grow the protocol. The collective wisdom of this is worth billions of dollars of labor. And we get to harness all of that. We couldn't with the second generation. And we couldn't even possibly tackle the problems we're tackling in this industry, from DeFi to intellectual property and other things with Bitcoin. That's why everybody's trying to upgrade it. So what is the fourth generation? Do we need one? What do we care about? Well, you'll hear lots of terms like real-world assets, okay, security tokens, DAOs, business on the blockchain, all these things. Why don't we have them? It's like the flying car. It's like fusion. It's always 5 years away. Don't worry. Trillions of dollars are waiting. They'll come into our industry. Why can't we get there? Because here's the problem. Blockchains are super awesome at public stuff. They're auditable, timestamped, transparent, immutable. Good, great. You put it there like a domain name service. You put something there like a financial transaction. Everybody in the world can see it, believe it. It has integrity. Awesome. But what about the private stuff? What do we do with that? Do you like running a business where all your HR is public? You like running a business where all the money in the cash registers is public? How many people want all their Google searches to be public? Show of hands. Nobody? What about Amazon purchases? What about your political preferences? What about who you voted for in the election? Turns out that privacy is kind of part of the deal. And every real-world application, asset, business, transnational agreement always has two sides, a public side and a private side. The public side, we do well, and we're starting to master the art of programming it and scaling it and getting it done. But the private side is still something that's not clear, and in practice, how we're solving it is the same way we've always solved it. You pick somebody you trust, you give them the information, and you hope to God they don't lie, steal, cheat, manipulate. So if you have a blockchain application with a private and a public side, and the private side is off-chain and centralized, do you have a decentralized application? No. That's the first challenge. The second challenge is in the legacy financial world, and frankly, the real world, you don't have this idea of transactions without identity. You don't have this idea of businesses and no identity, assets and no identity. When you see a plot of land, what's the first question you ask? Who owns that? When you see a business, who owns that? Who? Something happened. Who were the people involved? What's the story behind that? So where is this in crypto? We have accounts, we have UTXO, we have transactions, and we have metadata, but where's the identity primitive of these types of things? The legacy world has spent centuries regulating and optimizing and figuring out how to answer the question who. How to adjudicate the question of who, the dispute resolution systems and the property rights systems and the transnational agreements. The cryptocurrency space doesn't. So how do I bring real-world assets? How do I build real-world businesses in a space that lacks a who? I have to invent one, a digital who. Horton heard the who. I need to have identity on the chain. So you have to have identity with privacy, because the minute you have who, you have to decide who gets to know, who gets to see, who gets to decide. You have to have this concept of selective disclosure. So the fourth generation, the generation that's going to merge the legacy and the Web3 world and bring billions of consumers in, really the two big pillars of this is, in addition to being scalable and interoperable and having good governance and programmability and decentralization, must have privacy, private smart contracts, and must have some concept of identity. The challenge is, unlike scalability, unlike interoperability, unlike decentralization, where there seems to be an obvious path of where to go and how to do that, more is better, cheaper transactions, faster transactions, and trade-offs, privacy is kind of a nebulous thing. What exactly does that mean? How exactly does that work? And also the same for identity. It took us as an industry 10 years of discussions and work to figure out how to create a standard just to represent identity. It's called the DID, the Decentralized Identifier, at the W3C. We worked on it. A lot of other people did. In fact, formed a foundation, the Digital Identity Foundation, 35 members. All these people came together, built frameworks. Great. Is that the game? No, we're not over yet. We have all kinds of things like, well, now you have a representation. Well, how do you prove properties of it? Well, we had to create a non-creds as a standard. What about your creditworthiness or your reputation management? That's a subjective, not an objective thing. Objective is, when were you born? Subjective is, are you a good person? Well, it depends on who you ask. Some people in this room like me. Some people do not. They're getting up and leaving. So, subjectivity of reputation. So how do you quantify that? How do you build marketplaces for that? This is the challenge of identity. The same for privacy. When you look at privacy, what are we actually talking about? Like, to whom? What guarantees do you get? What's the portability of that? How do you disclose that? How much overhead is required? Is it private forever to the end of time? Is it private for a little while? Is it private within a certain security model? So this is the next generation as we talk about these things. But then there's also a meta problem in the blockchain space. We've gone from too few to too many. There's more than 40,000 blockchains. There's millions of assets all around. We all have perverse incentives to hate each other, not pay attention to each other, dislike each other. Why? Because we have tokens. You have token A, and token B, and token C, and token D, and you put your names in, and you go and talk to these people, and if the person owns the token, it is virtuous and good. And if it's competing against another token, that token is evil and bad. Bag holding. That's the world we live in. And guess what? You can never build an economy where people's financial incentives are at risk. People, no matter what their politics and beliefs are, will always default to their incentives. It's a reality of human nature. So then how can we build a space that has interoperability and everybody's working together and collaborating and it's good for the consumer if the system, by its very design, promotes, incentivizes, and rewards fragmentation? It's a problem. So that's the fourth generation in a nutshell. Is there a way to have computational privacy? Is there a way to have identity? Is there a way to get around the incentives problem and actually get everybody to work together? Nope. All right. Well, anyway, it's been great. Actually, it turns out, the last 6 years, we've been thinking about this. We've been working on this. Input Output is a magical company. In addition to being a great engineering firm, most noted for building Cardano, we also have labs all around the world at Stanford and CMU and University of Edinburgh and Tokyo Institute of Technology, 168 scientists that work with us. We've published 223 papers, over 10,000 citations. Rigorous academic papers where we ask these questions in a very foundational way, a very fundamental way. We're thinking about it. And what we did with these papers is we tried to figure out a light blend of these types of things. And I said, you know what would be really cool? Because I've been in the space for so long, and I've gotten to a point where I just like solving problems. And I don't like working with the VCs, and I don't like the normal economics of this space. It would be really cool just to build something and give it to everybody that actually solves a real problem. So 6 years of hard work, we created something called Midnight. October 1st of this year, it's reaching the test net. It's been in the dev net for a little while. And if you go to midnight.network, you can build on it. And the first thing we figured out on how to do with Midnight is we created a private smart contract stack called Kachina. And you can write smart contracts in TypeScript. Anybody can do that. It's a pretty simple language. Second thing we figured out is we're building what's called a hybrid application model. So if you're an Ethereum, Solana, BNB, Base, Bitcoin, or Cardano developer, over time, you're going to be able just to basically query Midnight and do the private and identity stuff for your application. And you can pay your transaction fees with the underlying currency. Ether or Sol or Bitcoin or what have you. So you don't really care too much about tokens now, do you? We call these hybrid applications. They're good ideas. Now, it turns out it's really hard under the hood to do this, but that's what we do. We do the science part. And then there's a question of incentives and distribution. Ordinarily, because I've been in the space so long, I kind of know all the dirty tricks. What you do is you go to a VC, they give you a bunch of money, they get founder tokens, and then they dump on retail when the network launches. You know who you are. You do. And they make great money. And then the ecosystem collapses, and the next thing goes, the next thing goes, the next thing goes. That's not how we get ahead. So instead, here's what we do. Just do something called a glacier drop. So you take 135 million accounts across all the major cryptocurrencies, you just airdrop to them. And if people want it, they mine it. In the process of mining it, they launch the network. So that's how you get a fair distribution, right? Everybody gets it. Everybody has it. And here's the other beautiful part about that. In the process of doing this, we invented a new protocol called Minotaur. We wrote it with Shireen, who went on to create EigenLayer with the technology, and we created Midnight with it. And it's called Minotaur, and it's multi-resource consensus. And what's so magical and special about multi-resource consensus is it allows you to maintain a blockchain with multiple consensus protocols at the same time. You go talk to the Bitcoin maxis, and they say, proof of work. You go talk to us in the third generation, and we say, proof of stake. But you know what? You got to get your peanut butter and jelly together. So why can't we hybridize things and bring all the consensus protocols together? And guess what? If you have the validators maintaining the state of the system together, you can pay block rewards to them. So you start looking like a layer 2 to everybody. Doesn't that bring everybody together if every system is working together? So that's Midnight. It solves real problems. If you hold any of the major cryptocurrencies, you already own it. Congratulations, you're welcome. Papa Charlie took care of you. You got hybrid applications. You pay in the currency that you know and love. You don't have to actually do anything. You don't have to leave the network effect of your network. And you can borrow security and consensus from all the other systems. And because you're doing that, your consensus layer is directly observing all of the major cryptocurrencies, which means you're also the single best oracle chain and bridge system around. And because you have all the privacy tech, what do you have? You have recursive snarks, which, by the way, are also upgradable because we care about these things with love. I'm Italian. You have to make things with love. And because of that upgradability and because of that recursion, it also means that you can use it as a data availability layer. All kinds of magical things. So that's the fourth generation. It's the generation that brings us together. It's the generation that gives us identity. It's the generation that gives us our privacy and for the first time ever allows blockchains to keep a secret. And it's the generation that opens up the floodgates and allows us to finally have the trillions of dollars of real-world assets that are waiting on the sidelines that require these things to come into the cryptocurrency space. That is the last generation we need. Because at that point, everything is just iteration. At that point, everything is just, is it the right asset or is it the right partner? But this is what's going to bring the medical records in. This is what's going to bring ESG in with supply chains and measure the carbon of every business in the world. This is what's going to bring the financial markets in because you don't have to reveal your trading strategies to trade on chain. This is what's going to allow you to have DAOs that live 100% on chain because the DAOs, for the first time ever, can keep a secret. And thus, a real business can be on chain. And you know what? By giving it away to everybody, like Satoshi did with Bitcoin, just mine it if you want it, it means the whole industry, for the first time ever, has one thing that they can care about together and agree about. I have 30 seconds left, and I'll spend them this way. Great things in life come as a result of working together and cooperating with each other. The Apollo mission had 1 million people work on it. And those people are proud because the end result was that they got to go to the moon. If we want to go to the moon and beyond in crypto, we have to start working with each other, and we do that by giving each other incentives to do so. So thanks for spending 20 minutes with me and learning about the generations. I really appreciate it, and I can't wait to see what you build on Midnight, and I can't wait to see the next 10 years of crypto. It's been a wild ride, and it's going to be even more wild. Cheers.